After studying this module, you shall be able to know about the historical perspective and need for a single international SI system, knowledge about the base unit measurements, derived units and line graphs. One of the very significant skill which early human being developed was ability to measure. According to one belief, people learned to measure much before they learned to write. And it was the capability to measure that people learned to count. During Peking and Neanderthal period, people carved tools out of the natural materials. Gradually, they learned to determine the right length or weight required for a specific determination, which was mainly in those times. A tool that worked well became the model and standard for developing more tools. Gradually, the methods of measurements and tool became more and more sophisticated and were converted into measuring sticks.
Let us learn about the historical perspective and need for single international system. 300 centuries before Gabriel Mouton in Lyons feel the requirement for a solitary worldwide corresponding measurement system and proposed in 1670 a widespread decimal measurement system grounded on the length of 1 minute of arc of a big circle of the earth. Mouton also suggested a swing length of a pendulum with a rate of reoccurrence of 1 beat per second as the unit of length. A pendulum with this beat frequency would have been fairly easy reproducible, thus attempt to simplifying the widespread distribution of uniform standard. Many other suggestions were prepared, but more than a era elapsed already. Some action was taken. In the middle of the French Revolution, that is, in 1790, the French Academy of Sciences deduced an invariable standards for entire the measures and weights and created a system that was at on one occasion seems to be simple and scientific. The unit of length was to be a proportion of the earth's circumference. Measures for ability and mass were to be derivative of the unit of length, thus connecting the basic units of the system to each other and to nature. Additionally, great and smaller multiples of each. Now let us learn about a brief history of measurement system report presented to the Congress in 1821 by John Quincy Adams. Weights and measures may be ranked among the necessaries of life to every individual of human society. They enter into the economical arrangements and daily concerns of every family. They are necessary to every occupation of human industry, to the distribution and security of every species of property, to every transactions of trade and commerce, to the labors of the husbandman, to the ingenuity of the artifice, to the studies of the philosopher, to the researchers of the antiquarian, to the navigation of the mariner, and the marks of the soldier to all the exchanges of peace and all the operations of war. The knowledge of them, as in established use, is among the first elements of education and is often learned by those who learn nothing else, not even to read and write. This knowledge is reverted in the memory by the habitual application of it to employments of man throughout life. Units were to be created by either by multiplying or dividing the basic units by 10 and its powers. This feature providing a real suitability to users of the system by removing the requirement metric units, which was most commonly used in scientific demonstration. Standard abbreviations and prefix has been accepted for them. Detailed explanation of prefix has been given, and some of them are abbreviated as follows. G means gram, M indicates the meter, L for liter, small m for milli, small c for centi, mu for micro, k for kilo, and n for nano. Now let us learn in detail about their prefix. Pico. It is symbolized as p with exponential form 10 raised to power minus 12, and its corresponding decimal form can be seen in table. Next is nano. It is symbol with n, exponential form 10 raised to power minus 9. Next is micro. Its symbol is mu, and exponential form is 10 raised to power minus 6. Next is milli. Symbol for milli is capital M with exponential form 10 raised to power minus 3. Then centi with symbol capital C and exponential form 10 raised to power minus 2. Deci with symbol capital D 10 raised to power minus 1. Deca symbol capital D and small a, exponential form 10 raised to power 1. Next, hecto, symbol capital H, exponential form 10 raised to power 2. Next, kilo, symbol capital K with exponential power 10 raised to power 3. Mega, capital M, and exponential form 10 raised to power 6. The decimal forms of the prefix is given respectively. The abbreviations for the units generally appear without periods. The examples are given further. Microgram, milligram, nanometers, centimeters, microliters, milliliters, kilogram. In denoting microscopic lengths, the unit micrometer is still quite often called by its old name, micron, and abbreviated mu instead of micrometer. The unit for 1/10 of a nanometer or 0.0000000001 meter has the special name angstrom unit and is abbreviated as capital A. After discussing the base unit measuring length in the previous module on the measurement, other base units associated to measurement is discussed. Next is the base unit measurements. Measuring mass. The variance among the mass and weight create a lot of misperception between people. To put simply, weight of an entity is a measure of the effect of gravity on that object. Mass can be defined as the quantity of substance in an object. If an object is taken to a other planet than Earth, its weight will change because of absence of gravity, but its mass will remain the same. In a laboratory, the mass is determined by using balances. While there are different kinds of balances available, they are all expensive and delicate instruments that need to handle with care. Most balances in use these days are electronic. An electronic balance has many advantages over other types of balance. The most noticeable in the ease with which a measurement is attained. All that is required is to place an entity on the balance pan, and the measurement can be observed on the display monitor to hundredth of a gram. A second advantage is being able to use the zero button on the front of the balance. Since we will not put a chemical straight on the balance pan, certain container has to be used. Place the container on the balance and mass of the vessel will be shown. By pressing the zero button at this stage, the balance will return to zero and overlook the mass of the vessel. The substance to be weighed poured into the container and the balance will show only the quantity of the substance, excluding the quantity of the container. This saves calculation time and strength. However, when the vessel is taken out from the balance, the display will become negative till the zero button is pressed another time. Next is measuring volume with a graduated cylinder. The surface of a fluid limited in a cylinder curves to form, which is called as meniscus. The meniscus of all fluids curves up the sides of the container, making the center of the curve appear lower than the edges. Then, reading the meniscus at the highest or the lowest of the curve makes a variation in the volume measured. It is normally decided to all the times observe the bottommost of the curve. The smaller the container, the superior is the curve of the lower meniscus. To measure the volume accurately, our eyes must be at the same level as the bottommost of the meniscus. This is the sign present on graduated cylinder that must be read. Use the graduated cylinder to measure the capacity of colored liquid provided in each test tube. Be sure to use the appropriate number of significant figures. Every gallon has approximately 3.78 liters. The two diverse spelling of the word liter or liter are used, which originate from the spelling difference between British and American English. In British English, used in most Commonwealth countries, it is spelled liter, while in American English, the word is spelled liter. Next is micro volumes. In a DNA fingerprinting laboratory, the ELISA laboratory, and other laboratories, there is an urgent need to measure every small volumes in microliters or 10 raised to power minus 6 liters. Such small volumes are measured with the help of a tool called a micropipette. Depending upon the accuracy and precision required, the micropipette or chemical droppers are available in different designs, varying from simple single glass pipettes to more complex electronic pipettes. Measurement accuracy varies greatly with the design of pipette. The first micropipette was patented in 1916 by Dr. Hans Sachmetz, the founder of the company Epidoff. The rights of commercial production of micropipettes were inherited to Dr. Heinrich Netherler. The adjustable micropipette is a Wisconsin invention developed through interaction among several people, primarily the investors Warren Gilson and Henry Laude, a professor of biochemistry at the University of Wisconsin-Madison. Next is air displacement micropipettes. Air displacement micropipettes are those type of adjustable micropipette that measured volume of liquid between about zero point 0.1 microliter to 1000 microliter. These pipettes require disposable tips that come in contact with the fluid. The four standard size of micropipettes related to four different disposable tips are shown in table. Pipette type P10 with the volume 0.5 to 10. Color white. P20 02 to 20. Tip color yellow. P200 volume 20 to 200. Tip color yellow. Next is P1000 with volume 200 2000 with tip color blue. Every micropipette manufacturer recommends the checking the calibration after every 6 months if used regularly. Next is positive displacement pipettes. These types of pipettes are similar to air displacement pipettes but are less frequently used. These are used for volatile or viscous substances at small volumes, such as DNA, and also used in avoid contamination. The major difference is that the disposable tip is a micro syringe made up of plastic composed of a plugger which directly displaces the liquid. Next is derived units. Since the 20th CGPM, which met October 9, 12, 1995, decided to remove the class of supplementary units as a separate unit class in SI system. The radian and steradian, which were the supplementary units, are now incorporatable into the class of SI derived units. Thus, the SI units are currently divided into base units and derived units, which together forms the coherent system of SI units. The SI International System of Units specifies a set of 7 base units from which all other SI units of measurements are derived or In other words, derived units are those units which may be expressed in terms of base units by means of mathematical symbols of either by multiplication or division. For example, the SI derived unit of area is the square meter, and the SI derived unit of density is the kilogram per cubic meter. The names of SI units are written in lowercase. The symbol of units named after persons, however, are always written with an uppercase initial letter. Example: the symbol for hertz is Hz, but the symbol for meter is small m. Next is density. The density is derived unit because the density is a mass per unit volume, or in other words, a unit of density is defined as a unit of mass divided by unit of volume. In turn, a unit of volume is a third degree of a unit of length. Mass and length units are base units, so density is a derived unit as derived from main units. When examining any object of evidence, density being an intensive property of matter may be useful in establishing objects' composition. Next is line graphic, the type of graph that best shows the relationship between two variables in the line graph. The line graph will usually be the most useful type of graph in this course. A line graph has one or more lines connecting a series of points. When plotting data on your graph, variable to place along the x-axis and which variable to place along the y-axis must decide. Usually along the horizontal axis or x-axis, the most consistent variable are present in the experiment. Along the vertical axis or y-axis, often the dependent variables are placed. After that, the scale of each axis is decided, that is, how much each unit along the axis represents. Scales chosen must make the graph as large as possible within the limits of paper and still include the largest item of data. If the scale unit is too large, your graph will be restricted into a small area and will be tough to read and interpret. If the scale unit is too small, then graph may run off the paper. So, scale units should also be selected for ease of locating points on the graph. Multiples of 1, 2, 5, and 10 are the easiest to work with. Now let us learn the physical quantities along with their units. Physical quantity, symbol, SI measurement units, symbol, units, dimensions. Distance, D, centimeter, meter, cm, m. Mass, small m, gram, kilogram, gm, kg, kg. Time, T, seconds, capital S, small s. Electrical charge, capital Q, coulomb, capital C, capital C. Temperature, T, Kelvin, K. Amount of substance, N, mole. Luminous intensity, I, candela, CD. Now derived units. Acceleration, A, meter per second squared, area, A, square meter, and so on. The official SI quantity is electrical current and the base unit is the ampere. Electrical current is the amount of electrical charge measured in coulombs per unit of time. In an effort to strengthen the public trust in forensic science findings, a committee in US in 2009 has been constituted to make elaborated recommendations which strongly supported to improve the standards for measurements and addition of new and innovative forensic science technologies to have properly validated procedures for techniques used in forensics examination to increase use of documentary standards and measurement services by the forensic community, creation of reference materials, databases, and new calibration services to improve the consistency of the implementation of forensic science across the nation, dissemination of best practices to strengthen the precision and reliability of forensic science analysis, development of rigorous training programs. National Institute of Justice and other agency like NIST has measurement science research underway in biological, chemical, radiological and nuclear detection and their analysis, fire and explosive analysis, gunshot residue examination, latent fingerprints development, and many other such areas work in DNA profiling and testing, for example, help them to establish the improved method presently used by all crime laboratories to match individuals to evidence samples. Next is expecting impact. A major outcome of this initiative will help to strengthen the utility and reliability of forensic evidence analysis in the courtroom. At the same time, it has the potential for significant cost savings.
Summary. It was gradual change in naming the units of length, weight and mass, like earlier it was the unit of length was to be a portion of the earth's circumference. Weight of an object is a measure of the effect of gravity on that object. The mass can be defined as the amount of matter in an object. The surface of a liquid confined in a cylinder curves to form what is known as meniscus. The micropipette or chemical droppers are available in different designs, varying from simple single glass pipette to more complex electronic pipettes. Thank you.